Before we start, I would request the participants to quickly type in the chat window some of the terms that you remember from yesterday's session. So the chat window, just type the terms that you remember from yesterday's session. Statistical data, that is what we discussed yesterday. Yeah, widget workflow, okay, regression, widget, data mining, classification, outlier, statistical concepts of data is orange data mining. Anything else? Okay, so most of you remember orange data mining. What are some of the statistical analysis that we did with data? You remember all the some mathematical. Okay, yeah, Swati Reddy ma'am has written mean, median, variance, mode, and anything else? Standard deviation, I didn't see that from anyone. Yes, standard deviation, okay. Variation, variance. Okay, so these
Typing a little longer on the chat window.
I'm so sorry.
Yeah, typing the keypad becomes very small during the video call. So the typing is getting difficult.
Okay, yeah, fine. I can understand. Yes. Okay, so yes, these are all the things that we discussed in yesterday's session. So we will start with today's session. Let me share my screen. Okay, before I start, I would like to inform you all that I hope you must be aware now. Yeah, so these are all the upcoming sessions of CS GEMS event. So there is one CS GEMS event planned in IISc Bangalore on August 23rd. Okay, and another one in Chennai. It will be on September 13th and it will be conducted at IIT Research Park. So if you are interested and if you want to be a part of this event, you can register. The registration link will be posted now and also at the end of this session. So interested participants, you can register and attend this offline event. So you need to go to this particular venue to attend the event. Okay, so let's start now. Okay, so computer vision. Now, if you see that the fifth lesson, okay, it's all about processing images and videos. Now, how many marks will it be conducted for? It will be for 4 marks. And this lesson is there both in theory and practicals. You can see this. Okay, so theoretical part also you need to cover, and in the practical also you need to have some activities to be done in the practical notebook also. Now also in the practical examination also you have to have that. You can see here practical examination also it is there. So how it is divided into practicals and theory. So that part we will see now. So computer vision to be assessed through theory. Now all the concepts of computer vision and its application in various fields, these things that is the introduction of computer vision. So that will be covered in theory part, and understanding the basic concepts of image representation, feature extraction, object detection, and segmentation. So these all will be covered in theoretical part. And there are some activities given here. So we will anyway do this activity. Some of the activities which we have done in bootcamp 1, I will not do it because they are very basic. And when it comes to practical part, of course, we will be using the orange tool and to classify the images, like the images of fruits, like classification of apple, banana, orange, and all. And 2 activities we will be showing, like yesterday, one is simple activity, the other one is little bit complex. and those two, okay, as suggested by CBSE. So we will do that activity in orange data mining. And what else the children should know? Image features and convolution operator. So how convolution works. Okay, so that part the students should know, and all the convolutional neural network layers, how it works, how it processes the images, and its application in computer vision and image recognition. So these all will be done in practical part. Okay, so we will start with the lesson now. I hope my screen is visible.
Yes, ma'am.
Okay, so I have opened the textbook now. Okay, so we will start. I hope it's visible. The textbook is visible. So anytime, whatever I am showing, okay, so I will be showing orange data mining when I'm doing the activity. In between, for further explanation, I will be using PowerPoint. And of course, we will be having this ebook. Okay, these are all the three resources. So if whatever I'm speaking is not matching with what you're seeing, on the screen, immediately let me know. And some of you had asked for links for data sets yesterday, and also for PowerPoint. So the PowerPoint that I used and the links for the data set, you will get it by today. So all of you will be getting it through emails. Okay. So let's start now. Can we see without eyes? So this is the question. With this question, the lesson is started. Now, if you see, Elon Musk introduced an app, okay, called Blind Sight. What it will do, even those who are not able to see, who don't have vision, okay, they will be able to visualize the world. How is it even possible? How can people who are blind can look at the world around them and interpret all the things that they are seeing? Okay, so with this question, with this curiosity, we are going to start this lesson. So what we will learn at the end of this chapter, what is computer vision and how images are processed, summarize feature extraction and convolutional neural network layers, and no-code AI tools to build image classification models and explore real-world applications of computer vision. So this is what we are going to learn today. Understanding computer vision. Of course, we have many apps. Even our phone can be unlocked using our face. Yeah, Snapchat has so many features called filters, which can be used to make funny faces. And while exploring a new place, our phones are a great companion. Okay, you can just scan a menu or sign or schedule, and the text is instantly translated. Okay, so all these things are possible with the help of this computer vision. Now, again, we all know that depending on the type of data, it is divided into three domains. Statistical data. Yesterday, we had a detailed discussion on this, and today it will be on computer vision. And the next lesson is on natural language processing. Now, what is computer vision? It's the AI domain where computers and other machine acquire visual data. They will be able to analyze it, and they can make decisions based on that. And how does it do that? Okay, so for that we will see how we do it. We human beings do it. What we will do, our eyes see the object in front of it, and then our brain, it analyzes what we are looking at, and then we will react based on what we understand. So that is how our brain also our brain process the images. Now, how computer vision does it? Okay, a camera, okay, captures an image just like our eyes. And then a computer processes the image, okay, just like our brain. And then the system makes a decision on what it has recognized. So based on its understanding, it will take a decision. And I hope you all remember we did this activity when we were in AI boot camp. First session. Okay, so the last session we did that, so I'm not going to do it. Okay, emoji scavenger hunt. Okay, now computer vision task. Okay, what all it can do? It can, of course, we saw that it will be able to analyze images and extract important information for further processing. This is a very, very important, extracting important features. Okay, and then it discarding the unwanted features. Now, how exactly it will do that? That is what we are going to see in this lesson. So it performs specific tasks to help computers understand images. So it focuses only on important details, which can be directly used for predictions or for further processing. Now, how it will do for single objects? Okay, it is divided into two types, for single objects and for multiple objects. When we talk about single objects, it is image classification and image classification plus localization. Now, what does it mean when we say image classification? It can assign a label or category to an entire image. For you can see here, okay, there is a CCTV. As soon as the person comes into that frame, it is able to detect it that a person has entered. That is image classification. And when we say image classification and localization, it is not only able to identify the person, but it is also able to tell precisely where exactly the person is in that frame. So that is image classification and localization. Now, if you see in image classification, the goal is to recognize and classify objects or scenes based on their visual appearance. So if you see the background, okay, that is the actual appearance. But when something comes in, okay, when there is another object entering in, then it will be able to identify that a person is has entered, okay. And when we say image classification, it is able to draw a bounding box, okay. It can identify where exactly the person is. So it combines classification and localization, means it determines both the object category, that it will identify that there is a person entered, and its exact location, where that person is placed in that location, that also it will be able to identify. So that this method is used while detecting a single object in an image. So this is applicable only for single image, okay. Now, if a security system not only detects the presence of a person, but also identifies where the person is in the frame, okay, that's what I told, where that person is standing. The person is standing very close to the gate or very far from the gate, okay. It will be able to, and it can provide a bounding box around the person to show their exact location. Even in our camera, you can see, like when we take a photograph, when you switch on the mobile camera, when you focus on the person and the background and everything, it will automatically put a bounding box around the person. And if there are 5 people, it will put boxes for all the 5 people. How it recognizes that these are the 5 faces, okay, or a single person, okay. So it detects. That is image classification and localization. Next, we will talk about for multiple objects. So it's here also it's the same. It will identify the object, and it will also do instance segmentation. What it means, for example, if you see this one, okay, identifying all the trucks in this image. So you can see there are multiple objects, and it is able to correctly identify all the trucks and all the bikes. It is able to identify. You can see that box, okay, the blue color bounding box around these objects, okay. So this task goes beyond image classification and localization. It is able to identify multiple objects in an image. It detects the object, it labels it, okay, and marks its position with the bounding box, even if objects overlap or appear in different sizes. So you can see this is little bit advanced. It doesn't stop just by putting the bounding box around each object. It can label it, it can mark its position, and also even if they appear in different sizes or in different even if they overlap, it will be able to identify. You can see this truck is far, okay, and we are not able to see it fully, but still it is able to identify it, okay. So traffic surveillance to identify and track multiple vehicles on the road by drawing bounding boxes around them. Now, what is image segmentation? Again, this is another advanced level. It not only detects objects but and provides bounding boxes. It also segments each objects at the pixel level. So it can distinguish the separate instances of the same class within an image. So you can see the background is one instance and the person, that is another instance. So what it will do, you can see we will do this in Photoshop also. Like we can just mark the outline of the lady, and then we can just delete the background and then bring in another background the way we want, okay. For example, yeah, photo editing apps to separate a person from the background by outlining their exact shape. So Photoshop is the best example. That is image instance segmentation. So to understand this better, you can see that this is a image, this is single object, only one cat is there. So it is able to identify there is an object. Okay, so that is classification. And here you can see that it is able to identify the object and also where exactly it is placed, okay, in that frame. So it is putting a bounding box. This is for single object. And when we talk about multiple objects, you can see there is a dog and there are two cats here and there is a duck. There are multiple objects and it is able to identify all the multiple objects and it is able to classify them. You can see the blue box means represents dog and the red box represents cat, and then the duck is the bounding box color of the duck is green. And the next is image segmentation. You can see how closely exactly the outline of the dog. Okay, so it is able to precisely tell where exactly the object is. Okay, so again, this is for multiple objects. Now, understanding images. So when we say image, okay, we humans see the image as a whole thing. Okay, but though internally we also take the important features to identify the face or anything or any image, but the computers, okay, or the computer vision process the images in the form of pixel. You can see the computer break down the images into tiny dots of color called pixel. Pixel means you can just remember it as a dot. I hope you all know now. So the pixel is abbreviated as PX. It stands for picture element. How you can see a clay pot. When you see a clay pot, how it is made? It is made up of countless tiny particles of soil, and every image on computer screen is made up of these pixels. Now, how all these tiny particles of sand put together and tightly packed and they form a pot. Similarly, when we say image on the computer, it is all made up of tiny square dots or a circle dots also sometimes, and they are called as pixel. So it is a two-dimensional arrangement of pixels. So we have x-axis and we have y-axis. So the number of pixels on the x-axis and we can say number of pixels on the y-axis together form a picture. Okay, but if you multiply these two, that will be the resolution. We will come to that. So a pixel is the smallest unit of digital image and it represents a single point of color in it. Okay, now you can see in this image, if you take, okay, like we will just reduce further. Even in if you zoom the picture very closely, then you can see the small square. So each colored square that you see is called as pixel, and every pixel will be of different color according to the image. Okay, now there is one app called pixelapp.com. So this is very interesting. The link is given in the book. Children can use it, and with the help of pixel they can draw an image and they can also create an animation. This activity also can be given for students to do in the lab, how pixels are used to create an image and how it can be turned into an animation. So after it is done, it can be exported as GIF for animated image. Okay, so yeah, when we talk about resolution, it is the number of the image is made up of pixel. The more pixels are used to create an object, of course the clarity will be good. Okay, this is known as resolution. That's why we say, like, whenever we want to buy a camera and all, we want to go for higher megapixel, only then the quality of the image will be very good. Okay, so resolution is directly related to pixel. And so as I told you, the pixel means in the horizontal and vertical dimensions of an image. For example, suppose I say solar system image. So I'll just click on the image. You can see the pixel. Yeah. If you see here, this pixel 1000 into 1080. So this is the horizontal number of pixels and the vertical. So in the vertical y-axis, it has 1080 pixel, and in the horizontal axis, it has 1000 pixel. Maybe I will show another image of this way, then it will be easy to understand. Yeah. You can see here 3,840 pixels are there in x-axis. Okay. And then 2,160 pixels are there in y-axis. So when you multiply 3840 into 2160, that is the resolution of the image. Okay. So if you want a very good resolution, then the number of pixels in the x-axis and the y-axis should be higher. Means it should be more. The more number of pixels, the quality will be better. Okay, so that is what it is explained here. Okay, so in another way also you can represent. So this is the way 1280 into 1024. Okay, so this is means x-axis and y-axis. There is another way to represent the pixel. We will say 13 megapixel camera. So what does it mean? If you multiply the pixels in the x-axis and y-axis, then what you will get? You will get 13 megapixel. So that we will call it as 13 megapixel camera. That is 1280 into 1024 means it is this much 1310728, or we can say 1.31 megapixel. Okay, so that's how we can represent the resolution. Now, what is a pixel value? It is pixel value in an image has a brightness and color represented by a pixel. That is, each square has a pixel value. So this value is essential in forming an image. Now, and every pixel value is a byte image where each pixel is stored as a 8-bit integer. So one pixel, okay, for example, if you are seeing the value 3, then that will be stored as a byte, okay, in the form of 8 bits inside the computer. Now ranging from 0 to 255. Now to understand this, I will just go to maybe do here itself. I'll open a Word document and I will. Okay, so when we say there is one pixel, okay, used for each one pixel, one bit we are using, then how many combinations are possible? So it can be either 0 or 1. Okay, so if we are using 1, then it can be only 2 possible combinations are possible for 1 bit. If we use 2 bit, then how many combinations are possible? So it can be like 0 0 or 0 1 1 0 1 1. So totally 4 combinations are possible. Here 2, here 4. Now when we use 3 bits, how many combinations are possible? So it can be 0 0 0. This is one possible combination, or 0 0 1 0 1 0, or 0 1 1. Okay, this is possible. Or like we can add 1 0 0. Okay, so again 1 okay,
0 1 1
0, yeah, 1, and then I'm not having space here.
1 0 1.
Yeah, so it will be 1. So the easy way to write is, see, I will write this way. So 0 0 0 0 1 1 1 1. Okay, 0 0 1 1 0 0 1 1. Otherwise 0 1 0 1 0 1. It's easy to remember instead of writing that way. So we will not leave any combination. Okay, so these many combinations are possible. So if you see, there are 8 combinations. So when I have 1 bit, okay, 2 combinations. So how is it possible? It is 2 to the power 1, because when we say binary, it has a value of zeros and ones. So we will always use the base as 2. So when it is 4, the base is always 2, and this 2 we are using. So it is 2 to the power 2, okay, which is 4. When we use 3, it is 2 to the power 3. Okay, so which will be 2 into 2 into 2, 8 combinations are there. So when we say byte, when we use 8 bits, then it is 2 to the power 8, which means 256 combinations are possible. Two 56 combinations are possible. Okay. Yeah, 256 combinations are possible. So that's how when we say 256 possible combination, it is 0 to 255 colors are there. Okay, so what does 0 means? It represents black or no color, and when we say 255, it means white or full color. So in between, everything represents different shades of gray. Okay, now compute. This is what is explained here, 2 to the power 8, which is 256. So total number of colors will be 256, and then that range will be from 0 to 255. So each value, okay, represents one color. Okay, a shade of color. So when we see grayscale, you can see that this is how it will be. We will also do one activity to understand this. So the size of the grayscale image is defined as height into width, and you can see this is how it will be. A grayscale image means we will have only black and white images in between the shades of gray. Now you can see here, when we take the image, every pixel, every square has an value. Okay, that is how the image is stored in our computer. Okay, so every square, what is written there? In every box, a number is written which represents the color. Okay, so when it is 255, then it will be like completely 255 represents what? Yeah, white color. It will be totally white. And when we say 0, when 0 is there, then it means that it is completely black color. Okay, now when we take RGB colors, then means for colored, okay, colored images, then there are 3 channels, one for red, one for green, and one for blue. So they will be like layers. Okay, one channel for red color, one channel for red color, and the pixel value ranges from 0 to 255. Again, the same applies for blue channel and green channel. So you can see here, this is how it will be. We will do one activity. We can just do this in, yeah, this link you can share with your students, and they can see how choosing different color combinations changes the color. Okay, so we will just see this. Okay, maybe here also we can see. Yeah, I hope you are able to see this box. You can see here there are 3 colors, red, green, and blue. So when I write 0, 0, 0, okay, in all the boxes, you can see there is a black color here. So let's see what happens when I write 255. Okay, so when I write 255 in red, I'm getting red color. Okay, and now I will write again 255 for green and 255. Okay, then you can see I'm getting the new color. Okay, the old color is yeah, you can see here 0, 0, 0 represents black color, and when I write 255, 255, 255, it is turning to white color. Now if I give 0, okay, for red and blue, then I'm getting green only is having 255, so I'm getting the green color. Similarly, if I write 0 for green also and then write 255 for blue, then you will get blue color. Now you can see there are some combinations given here. So for example, I want orange color. For orange color, the red channel should have 255, green channel should have 125, and the black channel should be 0. So let's try that. Red channel 255 and green channel 125, and the blue channel should be 0. See, you got the orange color. So how children, when they use in art painting classes, how they have these colors and they use the brush and then mix various proportion of the colors, okay, and get a new color. It's the same thing. Okay, same thing they are doing digitally. That's it. So that's how they can bring in new colors. Okay, here. So there are some combinations given here. You can ask your students to try. So now I just did it with word paint because they should know that here also it works the same way. And alternatively, you can also share this link and they will be able to see how giving different numbers for different channel bring new colors. Okay, now you can see RGB, this is how it will be. And then based on the number, then it will be formed like this. So the red channel, green channel, and the blue channel. Now, if you see, the red channel will have values like this, followed by green channel, and then the blue channel. So you can see there are three numbers, 53, 14, 165. For 1 pixel, 1 pixel, we will have three numbers, 53, 14, 165. That is the color combination in the top left of this image that we are seeing. Okay, so this is how it is showed in the grid. Now, with just 256 levels of RGB channel, of course, we can represent 16.7 million colors. What does it mean? It is actually the red channel has 256 combination of colors. Again, the green channel has another 256 possible combination, and the blue channel has another 256 possible combination. So it is 256 into 256 into 256. So that many color combinations we will have in RGB channel. Okay, to combine together, we will get that. Okay, so next is feature extraction. So when we say feature extraction, we will just take an example. So we must have seen in some earlier days, they will show the eyes or the lips of some popular personality, and they will ask the viewers to guess what is the who is this. Okay, so they can show the hair also. Okay, they can show the skin texture also, but these things will not be, these clues we will not be able to guess a person. Okay, what we need is unique feature of that person. What are the unique feature of the person? The eyes, the nose, the lips. Okay, these are all the unique feature. Using this only we will identify the person. So that is what is called as feature extraction. How we extract the important feature. So when we show someone's hair, it is not possible to identify them because hair is not a unique feature for a particular person. Now, how exactly this feature extraction happens? You can see even if there is a transparent image and water is also transparent, glass is also transparent, but still we are able to identify. How? Because of the edges. Okay, you can see the water is pouring and we are able to see the edges, and there are some bubbles or forming, okay, inside the water, and that also with the help of edges we are able to identify or visualize it as water being poured into a glass. Even when you close your eyes and just touch something, only when you come to the edges of that object, we will be able to tell, okay, yeah, this is this object. Okay, so when it is a plain surface, we will not be able to identify what is it. The moment we see some sharp curves or some bends, then only we will be able to tell, okay, what is that image. Yeah, this is one example. You can see this is a boy's image. Okay, now what are the unique feature? A and B, definitely not unique feature. Okay, and then the fragment C and D. These two segments are unique features of this image. Okay, to identify this person on the image. Now, the computer vision system looks at images in small parts and finds out key features. This is called as feature extraction. Okay, in order to identify, when this image is fed into computer vision, what it will do, it will try to identify what are the key features of the image. So that process of finding out the key features of the image is called as feature extraction. Now, if you see in this image, okay, the building image, okay, it is divided into 6 segments, A, B, C, D, E, F. Now, which segments are very unique for this image? You can see B is not very unique because it is plain. This portion can be anywhere on that on this image. And again, when you see D also we will not be able to find out. Okay, then it is not unique. And F also, like everything looks plain. Okay, everything looks the same here. But when you see A, the segment A, C, and E, we can clearly tell which portion of the image that it belongs to, like exactly how we will do in jigsaw puzzle. Okay, so it's the same way. Okay, so you can see A, C, E are the features, okay, of this image. Okay, B, D, and F will not help us to find out which position or which location that part belongs to in this whole image. Now, when we see on the right side, there is a green color box. Okay, and then, okay, the image is that green color. Okay, now you can see there is a blue box, there is a black box, and there is a blue box, black box, and red box. Now, which is very unique to this, to identify this green shaped rectangle? Can you just type it in the chat window? Can you type in the chat window box A? Let me see. Yeah, box A is unique feature. Why? Because this one, the B box, okay, if you see, wherever you move around the image, it will look the same. You cannot differentiate whether it belongs to exactly this particular area. And this black color box, okay, the C box, okay, this segment also, if you move along the horizontal way, if you move it horizontally, it can belong to any of the place. We cannot tell it belongs to exactly the same place. So these are all, the A is the good feature for this. So that is how the computer vision does it. Okay, now that we know computer focus on key features rather than analyzing the entire image, so let's see how they can achieve this. So that process is called as convolution. It helps computer process the image on specific features, as I told you, edges, texture, and patterns, rather than analyzing the entire image at once. So as I told you, when you are just closing your eyes and moving the your hand on the object, the moment you go to the edges, okay, at least you will get to know, okay, this is the this is the length. Okay, this is the, okay, there is a sharp curve, or there is some protrusion. Okay, some bump is there in that. So we will get to know all of these things using textures or patterns. Okay, if something is soft, you will know it is made of fur and all. But how does the computer detect edges and sharp features like corners? Okay, we touch and feel it, but how it does that? It uses a tool called kernel. Okay, so a kernel is a small grid of number that moves over the image. I would request Manju ma'am, like, would you please stop using this annotation, ma'am? Thank you. Okay, so it's a small grid of numbers that moves over the image. It's like a magnifying glass. It just goes around the image, focusing on small part at a time. Like what we do with the magnifying glass, we will be able to go in detail of a particular spot, okay, in what we are seeing. So it is like that. So it helps computer detect important details like the edge, corner, texture by processing each section separately. So this example I already gave you, like how I told, like if you slide your hand over the table, then the bumps are rough edges. Then you will identify that, okay, you can, at least you will get an idea of what you are touching. So as soon as your fingers feel a sudden change in the height, you know that there is a sharp edge or a corner. Okay, that's how we will be able to detect. This is what kernel also does it. It slides over different parts of the image. It scans the image from top left to the bottom right completely. It detects sharp changes in the brightness between the pixel. So as you can see, like a blue sky is there, and then a sun is there. Then it can see the difference in the color, okay, and the change in the brightness, okay. And these sharp changes help locate edges and corners. Then it will identify when there is a change in the color or when there is a change in the brightness. It will identify, okay, from here there is something else is coming up. Okay, that's how it will be able to identify. Now, what are these kernels? You can see for edge detection, This is this is the kernel values, and for sharpening this is the value, and for blur effect this is the value. Of course these numbers are fixed. So let's try to understand for edge detection what it is happening. Now you can see 1 represents one color and 0 means there is a change in the color. Again 1 is there in the first row, again 1 is there, it means again there is a change in the color. Okay, again if you see here in the next row 0 is there, from there is a change in the color, again there is a change in the color. So like that it will, this kernel will go around the image and it will see the sharp edges and the changes in the brightness and all. So for sharpening this is the value, kernel value, or for blur effect this is the value. Okay, now to let's understand this using this website. This will be easy. So you can see, this is also there in the textbook, image kernel. So as you can see, if this is the image, these are all the pixel values. Yeah, this is better to understand. Now I hope you are able to see a small box on the right side and left side. So as I place the box on a particular position in the image, it is also telling me the corresponding pixel value of that image. I hope you are able to see. You can see I'm moving my cursor. Okay, now wherever white is there, you can see if I go back, if I keep it there, okay, it is showing a value of 255. And if I just bring it down, you can see the values are changing accordingly. Narmada ma'am, please stop annotating the screen, ma'am. Yeah, when you start annotating, we are getting it with your name. So yeah, okay. So as you can see here, okay, you can just scroll this and then you will be able to see the pixel value. So when we see the image like this, but the computer will store the image in the form of pixel values like this. Now, okay, let's walk through applying a 3x3 sharpened kernel to the image of the face. So you can see there are many kernels available. Like these are also called as filters. So there are many, we will use sharpen, okay, or we will use something simpler. I want that edge one, it is not there. Okay, yeah, so let's see how it varies. As you can see here, this is the kernel, okay, that value, okay, that matrix, okay, the red color one. Now what it will do, the kernel, okay, will keep scanning the image like this. It will go here, again it will come to the second row and it will start again doing this. And you can see every time when the kernel moves around the image, the values are keep on changing. Okay, you can see how where exact position it is going. Now how exactly it is happening, we will understand from the textbook. Now let's assume that this is the image array, okay, and then this is the kernel array. We have this, they have taken edge array. Now what happens, we have to scan this kernel array over the image array, and then we will get this array. So how it happens, why the I star k, okay, so why here it has less number of grids than this. Okay, so I will show you, start from, yeah, okay, you can see this is the image array and this is the kernel array. What happens, this blue color one, this is where the kernel array is placed first. So what happens, this is the value in the image array and this is the kernel value. So what it will do, it will actually, yeah, so what it does, it multiplies 0 and 1, which is 0, plus 1 into 0, plus 1 into 1. Again, it will do for the second row, 0 plus 0 into 0, plus 0 into 1, plus 1 into 0, plus 0 into 1, plus 0 into 0, plus 0 into 1. This is how it is doing. And when you add everything, you will get 1 as the value, which is written in the array. Okay, so this process, what we did, it is a convolution process. We just did for the left portion of the image. We have to do it for the entire one. Now we have done for this. Now what we have to do, we have to place the kernel for these 3 grids. Okay, the same kernel will be placed for these 3 grids. Now we will see how it is done. Yeah, as you can see here, now the same kernel, okay, it is placed on the blue color one. Here it is placed. Okay, this is the value in the original image, and this is the kernel value for edges, detecting the edges. Now again, what it will do, it will like 1 into 1 plus 1 into 0. You can see here. Okay, the same way it will multiply, and then it will write the number here. It is a very simple like a multiplication and multiplying each grid and adding all the grids together. Okay, that's how you will get the value. Now, why this, the final grid has less number of boxes? I will show you as we scroll through. Okay, the rows we will see now. Let me delete this. Now you can see the original image has 1, 2, 3, 4, 5, 6, 7 rows. Whereas here the output we have 1, 2, 3, 4. Why is it so? We will see first it will do this. It will take these 3. Okay. And then once it does for the complete row, it goes to the second row. Now it will do for this. So we are having the first one and this is second one. And now it will do for this. Okay, this is third one, and then it will do for this. So fourth one, and then these 3. So fifth one, only 5 we will get. It's the same way that will happen for the horizontal way also. So it will take the first 3. Okay, this is the first one, and then it will take the next 3. So this is second one, and then it will take this 3, so this will be third one, and then it will take from here fourth one, and then from here fifth one. So that is how the kernel will be like moved around, and then the values are calculated and placed. Let us go to that website. Yeah, sorry. Here. Okay, so as you can see here, the kernel is given as the dotted boxes. So as I scroll through, you are able to see how the values are changing. So the value in the original image grid will be multiplied with the kernel value, and then all the values will be added together. Okay, so this we are doing for sharpen, and there are many ways. Okay, when we want to sharpen the image or when we want to blur the image, this is the kernel value. Okay, and as we move over, so this is how it is getting blurred. The image will get blurred. Okay, so you can see it is done for the first row. The process is explained. Okay, you can see it is done for all the first. Horizontally it is done. Once it is done horizontally, you can see it will leave the first row and it will go to the next row. Again, it will do it horizontally, and then it will start from the third row. That's how it will be done. Okay, so you can see, fill in the blanks in the resulting array with correct values. Perform the convolution operation using the given array and kernel. So this task can be given for practical. You can give an image array, you can give a kernel, and you can ask your students to get the correct values. Once the convolution process is done by applying the kernel value, what will be the final image value? So that this can be given as a practical activity for the students to write. Now, when you see the resulting image is smaller than the original one, as you can see, this is the 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so 6 rows are there and 5 columns are there, whereas the final one has 3 columns and 4 rows. Why the size is getting reduced? Why? Because you can see the first, when we move the kernel around, the focus will be from here only. Okay, you can see this part. Just unmute and show you. The focus will start from this position. Okay, and then it will go to this position. Okay, so the first row, last row, and the left side, this part. Okay, and then this part and this part will not be covered. This part will not be covered as we scan. Means when I say cover, the center value of the kernel. This part will not be covered in the original image of the top row, right side column, bottom row, and the left side column. So if we want that to be covered in all the areas of the image, then what we should do, we should add an extra row on the top and the bottom and the right and the left column and the right column, and then keep the values as 0. Okay, because anyway, if we have it as 0, it will not have an effect. And then we have to, the kernel will scan through the image. Now, if you see the very first time, where will the kernel start? The kernel will start from here. Okay, and what is the center value? This one. Okay, so you can see that no portion of the image is left over, and every portion of the image is scanned through, and then you will get the correct, the same rows and columns you will get. In the final one also, you will get the same rows and column. Okay, the rows and columns will not get deleted. The final image also will be in the same size. Okay, so I hope it is clear. Okay, now convolutional neural networks. Okay, so we have learned about artificial neural network that process information just like human brain. It can learn, it can recognize the patterns from data, it can make decision and improves over time. But to process visual data, means to process images and videos, we will go for convolutional neural network, CNN. So you should remember, ANN is for data processing and CNN is for visual data processing. Okay, so a CNN is a deep learning algorithm that analyzes images. How it will analyze the image? By detecting the key features and distinguishing objects for recognition and classification. So what are the key feature? Any object that it sees, it will identify the key feature. For example, this is an input image and this is the convolutional neural network. The image goes in and there are multiple layers. Okay, like how we have in ANN, we have input layer and hidden layer. All the processing will happen in hidden layer and then the output layer. Here also, we will give input image and the processing image. That will be done using convolutional neural network. The processing will happen and then the output probability value will be given. So it will be able to predict car is 70%, truck 20%, like that, bicycle and all. Okay, now what are the CNN consists of multiple layers? What are the 4 layers? Convolution layer and rectified layer unit, pooling layer and fully connected layer. So these are the 4 layers of convolutional neural network. So I've just made a PPT. With that we will learn. It will be easy. Yeah, so you can see convolutional neural. Yeah, so we will just see. So this is the raw image. It will identify the edges. Okay, you can see from this image, it will get this one. And then what are the most important features in that, the parts of the face. And then it will be able to predict the image. Okay, now when we say convolutional neural network, the first layer is convolutional layer. So this is the layer which identifies the feature. Okay, as I told you, think of it like a magnifying glass that slides over a picture to look for pattern. When we want to arrange a jigsaw puzzle, what exactly we will do? You can see the person will see the edges in the board and the person will see the edges in the puzzle, and that's how the person is able to keep the images correctly. I hope you were able to see this. Edges on the board and the edges on the puzzle, both the person will try to match and place it accordingly. So if you show a computer a picture of a dog, the convolution layer looks for small things. What are the small things? Basically, the edges, the corners, or the lines that make up the dog face, ears, or whiskers. It does this by scanning the image piece by piece by using kernel. Okay, so imagine looking at a puzzle piece by piece to see where the straight edges are, so you can find the border, like how we saw in the video. The next one is, rectified layer unit, okay, linear unit layer. This is called a highlighter. Suppose the image of the dog is given as input. So what it will do here, it will identify which is useful and which is not. Okay, you can see it will highlight. Yeah, only this part is useful because it has key feature, whereas other parts, they are not very important. So it keeps only positive values, that is important details, and throws away the negative values, that is unnecessary detail. This makes the computer focus on the strong pattern. I hope you are able to see this here. This portion of the image only features are there. The other portion, they all look the same. Now think of it like a highlighter pen. So when we study, we don't highlight every word. Whatever is important, that part only we will highlight. So here highlighting happens. Now in the pooling layer, what it will do, it makes the data smaller and simpler while keeping the important information. Now if you see the image, okay, the top portion is a very important portion. The bottom portion is not important. So you can see at the bottom, okay, if you see this image, this part alone, when you see it, we will think that it is a lion's body. Okay, but only when it is combined, this part only is telling that it is actually a dog's image. I hope you are able to just split it. So what it will do, it takes a small group of numbers and replaces them with just one. So the biggest number, we call that as max pool, but that is which has the strongest feature. So values will be big for that. Okay, here you can see the eyes, the nose, the tongue, they are all in different colors. So the values will be higher. So only that portion it will keep. And this helps reduce computer's work, but still keeps the main feature. So it will delete it will leave the below portion of the dog's image, and it will keep only the portion which is actually required. So imagine you take a group photo. Instead of carrying the huge file, we shrink it, but the main faces are still visible. Okay, that is what is happening here in pooling layer. And then we have fully connected layer. This is a decision maker. So after finding the features and shrinking the data, the final step is to make a decision. So now it will go through only the key feature, that is the dog's face that we got in the previous layer. So what it will do, this layer connects all the learned features. So how is the nose, how are the eyes, how are the ears, and then it will be able to predict that it is 90% dog and 5% cat and 5% a rabbit. Now the real life example, after reading clues, okay, in a mystery story, seeing the edges, shapes, and patterns, the detective makes the final decision on who is the culprit. Okay, so that's how it works. So the fully connected layer takes the decision. So you can just see convolution layer, it finds the feature, that is edges and shapes. Okay, and the ReLU layer highlights only the important parts. Pooling layer shrinks the data but keeps the main info. And fully connected layer, it only takes the final decision, that is the classifying. It will be able to classify whether it is a dog, cat, or whatever it is. Okay, now we will move on to the next one. So you can see that is what is explained here, same with the dog example. And how we will, now that we understand how CNNs work, let's explore how we can perform CNN without writing any code. That is by using no code AI tool. These are the tools that are available, and we are going to use orange data mining. Okay, so when you use orange data mining, you can see to process the images, you will not get that category by default. Okay, you will see only these categories: data, transform, visualize, model, evaluate, and unsupervised. If you want to process images, if you want to work with images, we need to install an add-on package, extra additional package named image analytics. How you will get that image analytics? You have to open Orange, go to menu options on the top, and then select add-ons. You can see here it is given. Okay, you can select add-ons. Okay, open orange options, add-ons, click on that and find image analytics. You will find this. Okay, image analytics, and then check the box. You need to just select this with the tick mark and click OK to install the package. You need to click the OK button to install the package. Only then the image analytics widgets we will get in our orange, and we will be able to classify the images. Okay, so this process I have already done for the tool, so I will not be showing it now. So I have explained it this way. Now let us go to orange data mining. Okay, so we will classify the object. So as I told you, we will do two projects now. Okay, one is the simple one and the next one is a little advanced one. Okay, so yesterday we discussed about installing Orange tool and all. So I hope you know the process. The link is there. So just go and install it. Yeah, so this is the welcome screen. I will close the welcome screen and I will show you all the category. Yeah, as you see here, you will get this image analytics only if you go to options and add-ons and then click. When I click add-ons, it will take some time. That's why I'm not doing it in the session now. I have already added it on, but you follow the step and bring this image analytics category here. Only then you will be able to have access to these widgets. Okay, and only using these widgets we will be able to process the images. Okay, now we will same way we will use the training data and testing data and do image classification. But as we discussed yesterday, it was about textual data, and today it will be about visual data. So let me show you how it is. Okay, so this is the data that we are going to work. Okay, so fruits training data. Okay, this is the first one, fruit classification. So when I open fruit training data, I have kept it in 3 folders. Apples. So there are multiple images of apple. So what you can do, before I start, I'll tell you, you can divide your students into groups and you can ask them to do some image classification project work, and you can tell them that suppose they are doing for flowers, okay, like lotus, lily and jasmine. They have to capture, okay, suppose there are 5 members in the team, then each one of you will take the responsibility of gathering pictures like this. So they will also learn image acquisition. Okay, so they have to gather multiple images like this. You can see many images of apples are there, and when I go to banana, many images of bananas are there, and orange also there are many images. So these images we are going to use to train the model so that it can classify the images. So it will go through it will take the shape, it will take the size, and it will take the color, and then it will be able to classify the images. So we will train our model using these images. That's what we are going to do. And you can see it is available in fruits testing data. So the project is to classify the fruits now. So let me open orange. Yeah, here. So now we are in image analytics category, and we will take this. Yeah, import images. Yeah, import images. Now from where we will import the image, I will double click this widget and I will click the folder here and I will select fruits training data set. First we are going to train. So fruits training data set, and I will select the folder. So all the images in this folder, there are 3 subfolders also, everything will be imported. You can see now 656 images are there. I hope you are able to see here 656 images and 3 categories. What are the 3 categories? Apple, bananas and orange. These are the 3 categories. So I will close it. Now, like yesterday, we want to see the images after importing all the images into Orange data mining tool. So I will bring in the widget called image viewer. Okay, everything is available in image analytics. So I bring in the widget image viewer, and I'm going to send the data, okay, from import images widget to image viewer. Now I will double click. You can see all the apple images, and then banana images, and then the orange images. As you can see, this is supervised learning. So every image has a label. Okay, you can see it is labeled. If it looks like this, then it is called as apple. And if it looks like this is called as banana. They are all labeled images because we are doing supervised learning only. Okay, now I will close this. We have seen the image. Now feature extraction. We learned that only. Identify extract the important feature from these images. Okay, so for that we will use image embedding. Okay, what image embedding will do, it will extract the key features, like the color is red, the shape is circle or oval. So it is actually identifying the extracting the feature. Okay, now once the features are extracted, we will send these features to a model. Now, which model we are going to use? So I click on the model. Today it is not linear regression. Okay, that is for predicting numbers. We will use logistic expression. So it is a classification algorithm, okay, to classify the objects. So I will bring in this logistic regression model. Yeah, sorry, I placed it twice. Yeah, logistic regression. And what I'm sending, okay, I'm telling use the feature, use the extracted feature, and the model is trained using logistic regression. Now, after this, we are not going to, yeah, next one is evaluate. So I'm telling make a prediction. So this is what you are going to do. Okay, we have imported the testing data, like the different kinds of images, and then we have asked it to extract the features using image embedding widget, and then the model is logistic regression. Now learn how to classify objects using feature using logistic expression. That is what we are telling, and then with that learning you are going to predict which classify the object. Okay, whether it's an apple, orange, or banana. Okay, now this is done. The training is done. Now we will bring in the test data that we have kept separately. So where is the test data? We will also see the test data once, fruits testing data. You can see that these images are used for testing separately. Okay, these images were not used while training. You can see there is a background there for this banana, and it was not like how the images we used for training. It is totally different. Now this orange is in a tree, and there are multiple apples here, which is kept in a bowl. Okay, so with this, we are going to see whether it is able to predict the classify the objects. Now I will go to orange data mining. I'll open this, and now again I will go to image analytics, import images, and double click on it. Click on that folder icon, and then this time it is fruits testing data set. And yeah, now you can see 7 images are there. It is giving information. There are 7 images for testing, and then I can again click on image viewer, send the data from this import images widget to image viewer. Now I will double click. You can see all the 7 images. So we have imported the images correctly. Now again, what it has to do, it has to extract the features, okay, in these images, in this test data. So for that, to extract the features of the images, we will use image embedding widget. And then which ones it has to use, the data it has to take from the testing data. So now we have used embedding in image extraction, feature extraction is done. And then with these features, you predict the classify the images. So what model is it is? So to make the prediction, use logistic regression model. And what is the data? Where is the data it is coming? The data is coming from the test data. Now with this, we will see whether it is able to predict. Now I will double click on this. You can see here image 1 2, 3, 4. Why image 1? The name is like this. You can see that is how it is stored. 1.jpg, 2.jpg. Here we will not use the name of the image because it is only going to give the name. Okay. So now 1.jpg is apple. That is what the logistic regression is predicting. Yes, 1.jpg is apple. Now what is 2.jpg? 2.jpg is banana. Has it predicted correctly? Yes, it has predicted correctly. Now what is 7.jpg? You can see 7.jpg is orange. So has it predicted correctly? Yes, it has made the prediction correctly. So it has made 7. So like that, all the images, it has made the prediction correctly. Okay, you can see this is the image name 1.jpg, 2.jpg, and yeah, this is also name. And then you can see size of the image, width of the image, and height of the image. And these are all the features that it has used to classify the objects. Of course, everything will be in numerical data, so we will not be able to understand, but this is how it has extracted the feature from the image, and based on that, it is able to predict the first image is an apple. Okay, so I hope it is clear. Now let's go for the next task, which is, yeah, I will show you the penguin classification task. Okay, so I will close this and I will also. Okay, so the next task. So we did this task now. How you can make your students to write? You can see again 4W problem canvas is there. And then, okay, define the problem statement. We need an AI model that can automatically classify the fruits based on their visual features such as color, texture, and shape. Now, who will get benefited and what is the problem, where it will be, like where is it used and why do we need to solve this? Again, data acquisition. Of course, the link is there, okay, where you can download the data. But there is one small correction needs to be done in the link. I think it is 10, like one more number should come here. I think it is 6. Okay, AIS 1006 should come. Okay, so like from there you can download the image. Okay, so modeling we have done, and then the logistic regression model we applied, and then the model was 1006. That is where you will find the data. In the first link it is given 100, just add 6. Okay, so this is done. Now we will go to the next application of computer vision. I'm not going to go through this. We all know this is again for theory part. Facial recognition, face filters like Snapchat, Google search by image, the reverse image. We type for the we search for the image and Google will give image. That is one way of searching. Sometimes we can upload the image and it will give information about the image. Okay, and computer vision in retail store. So nowadays Walmart and all, they capture the customer behavior and movements, which counter they are happy, okay, and then which counter they spend lot of time. So they will analyze all these things to provide better customer experience for the better shopping experience for the customers. And self-driving cars, it uses CV, and medical images to scan through to help convert 2D scan images into 3D models. Okay, so all of these things. And Google Translate app. Okay, you can click on any image and the text in that image can be converted to any other languages, making translation very quick. Okay, now we started with this. Okay, you can see how Elon Musk has made this blind sight app. You can just go through this. Okay, now I will go to the important part, the next activity. Let's scroll down. This is the activity. Classifying coral bleaching using orange data mining. Yeah, this one also I have shown you the same link where we just scanned the, we just ran the kernel over the image and how the values were changing. So you can do this activity. And the next one is coral bleaching using orange data mining. So under the sea nowadays, because of pollution and changes in the weather and atmosphere and pollution and everything, the color of the corals under the sea, they are changing. Okay, instead of like earlier they were very colorful, we call that as unbleached. Nowadays, because of issues, nowadays they are losing their colors. Okay, so they are actually getting bleached. Okay, from color to they are going like colorless. Now, who are the stakeholders for this? Again, who, what, where, and why is there? For starting, we will again start from data acquisition. Where is the data available? It is available in this link where you can download. I have already downloaded and kept. I will show you the data now for Coral. Okay, so we will see the training data set. So in training data set, there are two folders. One is unbleached. We will see these are all colorful corals. This is how it should be under the sea. But what happens nowadays, they are all like going colorless like this. You can see they are all in white color. If we detect this problem, then we will be able to find a solution and preserve these corals from losing their colors. Okay, so these are the two types of data, bleached and unbleached. Now with this, we will train the data. This is training data set. We will train the model. Okay, so I'll open and then click new. Okay, so how we are going to do it? Same way. First, we will go to image analytics. We will import the image. So I have done in widget. I am using import images widget. Double click and click on the folder and then choose the folder. So training data set. This is the Coral training data set. So I'm selecting this, select the folder. Now the images are getting imported. You can see there are 287 images and two categories. What are the two categories? Bleached and unbleached. These are the two categories. Once importing, let's use image viewer widget and see whether the images have correctly imported. So I am just connecting this. I double click. You can see all the images, both bleached and unbleached, all are uploaded. Again, it is labeled. We are using supervised learning model, so method. So every image is labeled. Okay, so all the bleached images and unbleached images, but from both the folders are imported. Now, after this, we have to ask the model to extract the feature. To extract the feature, use image embedding widget. Okay, and then connect the data, because this is the data. Use this photographs, use these images and identify the feature. Now, once it is done, we will evaluate. So we will use test and score. Or else before that, we can also use data table feature. And then, yeah, we can see here, this is the image name and it is clearly showing they are all bleached images are there and unbleached images are there. Basically, we are seeing the information in the textual form. The image name is there and then it is also showing the category. Okay, just like how yesterday we used data table, same way we are doing. Visualizing the information in the textual form. And now we will go to test and score. Where you will find test and score, it will be in evaluate category and then use test and score. Okay, so now we will connect this. Of course, we haven't used any model. We are going to do that. Which model we will see now. So we are going to try 3 models. Okay, and we are going to compare and see which model is better, like how we did yesterday. So the first model is, we will use is like how we did for fruit classification. We will use logistic regression. Now we will say logistic regression model and then connect it for testing and scoring. Okay, so the data is coming from the features. Okay, here it is not data. The features, the extracted features are coming from image embedding widget, and the model that we are asking, the method that we are using to train the model is logistic regression. Now I will double click on this. Like yesterday, you can see area under curve. Okay, classification accuracy, F1 score, precision, recall, everything, MCC, all the values are there for logistic regression. Now we will use another one. Okay, that is random forest. Yesterday we discussed random forest. Okay, now we will connect this model and to this for testing and scoring. Now I will double click on this, and when you see, now you can see that it is able to give a comparative analysis of these two models. Now you can see area under curve is 0.917 and the classification accuracy is 0.808. Whereas here the classification accuracy is 0.916. Okay, let's use another one called SVM. Okay, we are going to use support vector machines. Okay, this is another model. We will just drag this and we will use this model to test. Okay. Now you can see it is getting trained and it is evaluating the model, and that's it. We will click now. Okay. Now see the values and tell me which one is the good model to use for predicting the corals, whether they are bleached or unbleached. Can you just post it in the chat window? Which model is good? So that model we can use for our testing data. And that model can be used for deployment also. Yes. Very good, Pragati ma'am and others. Okay. Ma'am, I'm asking for model. Yeah, the good model is logistic regression. Why? We will just take this classification accuracy 0.916 for logistic regression, and for random forest it is 0.808, and for SVM support vector machine it is 0.889. So we can easily tell that the values for logistic regression are very good overall. So we can say that logistic regression model is good. Okay, now that we have identified that, I'll just move this. Okay, now we will see when we say classification like bleached and unbleached and all, we can also see the confusion matrix. Now in evaluate, we will see this confusion matrix widget. Now if you remember, I think from the third lesson, okay, confusion matrix we are bringing, and after testing, we are also asking it to show, yeah, this is the logistic expression. This is the confusion matrix for logistic regression. You can see predicted and actual. So how many it is able to identify bleached and bleached? Yes, 129 it was able to identify correctly. Unbleached and unbleached 134. This is for logistic regression. On the left side pane, you can see random forest is there. So I click on the random forest and it is showing the confusion matrix. Here, the bleached and bleached, it is able to identify only 119. But unbleached and prediction and the actual, both are matching for unbleached, 1/3 for 113 images. And for support vector mission, it is 134 for bleached, actual and prediction, and 121 for unbleached, actual and prediction. Okay, now from this also we can see logistic regression is good. 129 and 134 images, it is able to predict correctly for bleached and unbleached. So this model is definitely good, we can say. Now that we have decided the model, that is logistic expression, we will use the test data. How we will use the test data now? Okay, so you can see here, we will again click on this image analytics, and then we will see how the test data is. Okay, so we will go to the folder and we will see this is training data set. We will go to test data set. Okay, in the test data set, you can see they are not classified as bleached folder, unbleached folder is not there. The moment I click test data set, it is coming like this with just multiple images are there. Some are colored bleached, some are unbleached corals. Okay, here we are going to use this data set to test our model. Now, how we will do it? I'll go to this and I will say import images widget. I will double click it and click on that folder icon, and I will say test data set for corals. So I will select the folder. You can see 55 images are there. Okay, I can use image viewer, connect it, and then just look at the image here itself. Okay, you can also look at the image here itself, and I will close it. Now, next images means it is always feature extraction. For feature extraction, the widget is image embedding. Everything, whenever I say image, it will be in image analytics category. So image rendering. So I'm saying use this data, test data, and find the features. Okay, once you have found the features, we want the model to predict. Okay, so we will go to evaluate and we are telling predict. Where are the prediction? Yeah, prediction. Okay, so we are telling you make the prediction. Okay, so this is the data to make the prediction, and which is the model we are using for prediction. We found out that logistic model is good for prediction. So we are telling use the logistic model. So the data is there, and we are also telling you are going to use this model to predict. But you can see the lines are dotted. It means the logistic expression model is confused. Now how I have been trained. Okay, how did you train me? It is asking. That is why the lines are dotted. Now we are telling that how I trained you using these features from the training data set. You do the same way for this testing data set. I hope it is clear. Okay, I'll put it here. Okay, so I'm using the logistic expression. You can see if I don't make this connection. Okay, now what does it mean? I'm sending the feature extraction data from test data set, and I am also telling this is the model you are going to use. That is logistic regression model only you are going to use. But whenever you see the dotted line, it means that insufficient input is there. Okay, the inputs are not sufficient. Why it is not sufficient? We have to also tell the logistic regression how I trained you using the training data set. The same method you apply for this test data set. You can see once I make this connection, the dotted lines are gone and you are getting the proper line. Now we will double click on this and you can see here image name 1, that is 1.png. It is saying that it is a bleached data set. So we will open our folder and we will see, yes, 1.png is a bleached data set. We will take randomly some other thing, maybe 219.png. Okay, let's see whether it has made the prediction. 219, yeah, 219.png is unbleached data set. Yes, it was colorful. If you see here, 219 is colorful. Let us take this 223. Okay, this 223 png, what is the, where is the 223 png? Yeah, 223 png is bleached, means it lost its color. So like that, it has classified the images as bleached and unbleached for all the 55 images that we uploaded, and it has made the prediction. Okay, let me. Yeah, so this is how you have to make the connection. I hope these connections are very clear how you have to make. You should make it in the correct order also. And whenever we say workflow, we have to remember it like a story. Why I'm doing it? Okay, why I'm connecting this and this? Okay, what does it mean actually? So only when you know this as a story, okay, all the connections, like when we say a story, first line and the second line, there is always a link, right, between the first line and the second line. So that part we should remember when we create a workflow in Orange data mining. Okay, so these are the two activities you can ask your students. As I told you, you can give them as group activities. Divide the students into multiple groups, ask them to choose whatever they want to do, whether it is for corals or whether it is for flowers, anything that they want to do. They can start doing it from image data acquisition. Like they all have smartphones these days. Okay, they can divide themselves into two groups. They can say like, I will collect the data for one classification, and the other group, other members can collect. So they just need to take pics and upload in the drive, and then they can make. So every group will come up with a different project. Okay, in this case, we are not splitting the data. We are actually divided the data set in two different folders, and we are uploading it separately. That part we are not doing it here. If you want to club that also, of course, you can try it. Okay, so you can split the data and you can test it. That's it from my side. Anybody having any doubts, you can ask me. Any
The
doubts
session
you
was
can
very
ask me?
good. Only thing is, I think we need to use the orange data mining extensively to get it, get the feel of it.
Yes, ma'am. What you can do, like now that you have watched, install the orange data mining, just practice it, ma'am. Like a story,
Yeah.
if you remember and do it, then it will be easy for you. Instead of just remembering, connect this widget and this widget. So the
Yes.
children should know why I'm connecting these two widgets. So that is
Yeah.
very important.
Yes, ma'am.
Yes.
But otherwise, it was really helpful.
Yeah. Thank you so much, Sudharani, ma'am. Okay, yeah, Ambali ma'am, yeah, many have asked for PPT. Yes, I will share the PPT along with the links. You will, we will send it to you through your email. Okay. Any doubts you can ask. Otherwise, I would request the team to post the feedback.
Are we supposed to have random forest and the SVM model also in it? Like you have suggested that logistic regression will be the most appropriate for the same as per the accuracy. So can't we remove the random forest and SVM from it?
Oh, yes, you can remove, ma'am. No issue. You can remove.
Ma'am, will it impact on the output?
No, okay, I will show you. This will not have an impact because we haven't connected it. So this will not have an impact. I can just delete it because we are using only logistic regression, right? So that we have made the connection here.
Okay, ma'am. Okay. Because for grade 10, it would be quite difficult. Some that telling them the linear regression, then logistic regression, then classification, SVM, when to use which model, ma'am. How
Yeah,
can
okay.
we explain this?
Yeah.
Like linear and logistic regression, they have learned only a term regression.
Yes, ma'am. Thanks for asking this. Yeah, I forgot to show you. I told you I will show it later. Thank you for asking this. Yeah. You can see logistic regression, like linear regression, it will take a decision based on yes or no. Like this is used for decision maker. Okay, when we say random forest, I hope you remember multiple people trying to predict something. So you can see random forest is like a group of friends voting to make a decision. Each decision tree, like many decision trees are put together in taking a decision. So the random forest combines all opinions of course, and the majority wins. When we say support vector machine, it is like a best separator. It is like on the ground, you draw a line and you ask team A to be this side and team B to be the other side, and no one crosses it. Here this also it's like that. It's like a line drawer that tries to separate two groups as clearly as possible, like the bleached data corals and the unbleached coral. So it draws a line in 2D and plane in 3D, and then between two types of objects. That is support vector missions model. So that is how it is taking a decision. But in this case, we have a very simple data set. So this logistic, though it looks simple, like logistic regression is simple. Why it works in our data set? Because our data set, they are not live. If you capture images in live, then the data will be too complex. Now the data is very, very clear. Okay, the bleached and unbleached is very clear. Suppose we have sensors and we are capturing images continuously, then it makes the data set itself will be very complex, and we have to go for a very complex model which can take the prediction. Yeah, so that's it from my side. You can fill in your feedback form. Ma'am, you don't need to post your email ID here. Anyway, when you came for attending the session, all your details have been collected. So how you will get the certificates, the same way we will share the PPT also. No, ma'am, with this, we are ending this AI bootcamp. Swati Reddy, ma'am, Okay, with this, the sessions are getting over. I hope you would have seen in the feedback form link which session, which chapter you want to learn next. So we will come up with the next AI bootcamp based on the answers from most of you. Suppose you want to go for Python and then come for NLP. Okay, then if most of the participants want that way, then we will plan our sessions that way. So today we are winding up the session. So we will meet you all. I will meet you all again in the next AI bootcamp. Thank you so much, everyone, for enthusiastically attending the session and trying to learn. And it's wonderful to see your passion towards learning and teaching. Thank you so much, everyone. Ma'am, if your school doesn't have a branch, then you can just write your school name again, because there are some schools which has multiple branches. So that is what branch name means. If your school doesn't have a branch, just write your school name again. Thank you so much, everyone. Yes, ma'am, Subbalakshmi ma'am, it will be shared. Definitely, I will, in the PPT, I will add the links for the data set, because some of the teachers are asking for data set links. So I will add that also in the PPT, and then it will be mailed to you. All of you, all the participants.
Ma'am, excuse me.
Yes, ma'am.
Excuse me, ma'am. Ma'am, how can we contact to the person for the LMS and the book? Is there any contact number?
Ma'am, if you have Vasu sir's number, you can get in touch with him. Team, can you just post the number to whom they can get in touch with?
Okay, ma'am. I'm posting.
Thank you, Subramaniam sir. Thank you, everyone. Yes, ma'am. You can see here Vasudevan sir's number is posted. You can just send a message. But if you are filling only this time, this is the first time you are filling up the form, then it will take some time.
Thank you, ma'am.
Yeah, welcome.
It was such a wonderful and informative session for all of us for clearing the doubts. Thank you.
Yeah, thank you so much, Tarunava. Thank you, Harish sir. So if you wish to be part of CS GEMS event, you can register for the same. I hope you got the link for that as well. So if you are in Chennai or Bangalore, you can attend the session. It's a live event, so you need to come to the venue and attend the event. And that will be a very great learning for all of you. So just try to attend that. Yes, the link is posted for registration. And it's on Saturday, so that shouldn't be a problem for you all to attend. So
Ma'am, when will we get the certificate for the same, for this workshop, or 4 days bootcamp workshop?
ma'am, like the team will consolidate all the details and then generate the certificates, and then it will be mailed to you, ma'am.
Ma'am, will you people provide any bootcamp for students also? Because earlier CBSE was practicing for the same, but nowadays in the session CBSE hasn't declared for any bootcamp for grade 9 and 10.
Okay, ma'am, then what you can do, yeah, this is a very good suggestion, ma'am. We can also bring the students into our team. Of course, we will be happy to do that. You can do one thing in the feedback form. Any other feedback, please mention below. So maybe you can just write that. We will take that into consideration.
Ma'am, I have filled and submitted.
Oh, no problem, ma'am. Yes, we will think about it definitely.
Yes, keep my points in your mind.
Yes, yes, ma'am. Definitely, we will start doing something for students as well.
Good evening, ma'am.
Yes, ma'am.
A small query. can we have at the end of the session few discussion of sample papers? Like till now CBSE has not released the sample paper, whereas the portion is changed. We teachers are worried about how to prepare the students for the board. So such sessions which are giving us so much of information and it is of so much of help, we'll be thankful if you can discuss few important questions that you think that it is likely to come in the board exam. That I think it will benefit a lot of us.
Sure, ma'am. Yeah.
If possible, maybe say 10 minutes later. I'm saying in the next sessions, you may think about it. It's just a suggestion from my side.
Yes, ma'am. Actually, it's a very good suggestion, very valuable suggestion. What we can do, like instead of doing it as a 10-minute discussion after a session, we can also have a 1-hour discussion. Once the CBSE gives us the sample copy for the current academic year, we can have a discussion completely on how the questions will be coming for the board exam and how to prepare the students for the board exam according to the sample question paper. So we can have a 1 full hour discussion also we can have, ma'am. That's a very good
Thank you, ma'am.
Yeah, we will do that.
Thank you so much.
Yes.
Thank you so much. Have a nice weekend.
Yeah, thank you, ma'am. Same to you.
Ma'am, just a query, one more. This practical file we are having marks and then there are additional marks for project or portfolio. So what exactly are other schools doing? I just wanted to know what are the other schools like who are participating, what exactly is being done for portfolio, if you want to include portfolio, and what is for project. There is this bifurcation, you can do either this or this or this. Practical file surely you have to give, but other than that, portfolio and practical project. So what are the other schools, if somebody could just share that info, if any of the other participating teachers or even you, ma'am?
Okay, anybody wants to answer this? Anybody doing this?
Ma'am, may I?
Yes, ma'am, please go ahead.
Ma'am, actually, see, we have to take practical exam 2 times in a term 1 as well as for the term 2 also. So what we people have decided, for the term 1, we are going to take 20 marks for the portfolio and lab manual. Okay. And then 20 marks we have taken for the practical. In that practical, in the term 1, we are going to give some Python question and statistical data, 1 orange data mining question. And for the 10 marks, we have divided remaining 20 marks for Python and orange data mining question, 20 is for lab manual and portfolio, and 10 out of the 10 marks, remaining 10 marks, 5 marks we have given for the Viva of theory portion and 5 marks the Viva from the profile. So we have divided in such manner, and in the portfolio we are giving one problem. We are asking students to have a problem from their surrounding connected with the SDG and just design a complete solution for the same. Like they would be writing a data acquisition part also, then data exploration part also, and in this manner. So we did in the manner, and in term 1 we are checking the half, and most probably this time we are planning for an industrial visit also for these students. There some STEM projects and robotic lab are there, so some kind of visit is also there, because either portfolio, industrial visit, it is being mentioned. So we are planning in such manner. So for term 2 we are going to combine all of these marks.
Okay, thanks, ma'am.
So, ma'am, like whatever we explained today, see this choral classification and all, this also can be done as a project work. So you can ask your students to take any a real-time problem that they see in their day-to-day life, and then how they will be able to solve it. Okay, so that also using any of the they can use the model and they can classify it and then they can write. Okay, like ma'am said, like how they did the data acquisition. Okay, so from where they collect the images. They can say few I downloaded from internet and a few images I clicked it. So like that, how step by step they did the entire project. So the AI project cycle itself, you can just make the students, but they should take a problem that they see in their day-to-day life and then connect with what they have learned in AI.
Ma'am, do I share one project? Like recently, yesterday only I have checked for a student, and in that the child has taken the problem for the road lights in their society. And moreover, you won't believe उस बच्चे ने मैम ऐसा किया कि she has clicked the picture from her lane only. उसने अपनी गली के ही जो सोसाइटी है उसकी वहीं से ही उसने पिक्चर कलेक्ट किया. So then she returned that I have collected these pictures. Then exploring, she told ki I have removed such pictures in which the road lights are not visible, the pillars are not visible, or was the issue is not visible.
Or the clarity of the image was not good. So
yes. And then for the modeling, she decided ki like how can we place the solar panels in the society garden so that it can improve the electricity, and how can some LED bulb can be placed. So it was really good for me. मतलब out of the box, some child has thought कि उसने अपनी society का ये ऐसा problem उसने pick up किया कि it, and moreover she has connected it that how will it going to help to students as well.
Okay.
That they can sit in the garden and they can discuss, they can burn their stress there, and they can learn the things there.
Okay, yeah, it's very nice, ma'am. Yeah, if you just show them these things, the children only will come up with ideas.
Yes. We need to only ignite the ideas. We need to just initiate them, and then they come with the wonder colors.
Yes, true, very true, ma'am.
I speak. Can you hear me?
Yes, ma'am.
I'm Swati Reddy, teacher. Once again, I wanted to reiterate that how wonderful you have taught. And my next topic is computer vision only. So I was going to start my lesson plan tomorrow. So I'm very grateful for the wonderful explanation you have given. And yesterday's orange mining tool. And I may have said before that this is the first time I'm teaching AI. So I just wanted to ask my fellow participants here that how many periods do they get in a week? Does an external observer come over to actually see the practical work being done? How do they do that? If they can answer, I'll be very happy. Or if it's too late, it's okay. We can have this discussion some other time.
Yeah, ma'am. Yeah, if you have doubts like these, Swati ma'am, don't hesitate to post it in the WhatsApp group. I hope you are there.
Yeah, I can do that. Okay, I can do that.
Yeah, because see now there are only 40 participants are there. So just post it in the WhatsApp
Yeah,
group.
sure, I'll do that.
That would be better. So we can have conversations there as well, not during only the AI bootcamp. We will have the conversations going on in the WhatsApp also.
Yeah. And like another ma'am suggested, Ramya teacher, I would really love to have a session where we discuss the CBSE question papers, the questions that can come. So I hope you keep that in mind. Thank you.
Definitely, ma'am. Definitely. Yeah, we will definitely keep that in mind.
Thank you.
This is Pungudi, ma'am.
Yes,
Can you hear me?
Yes, ma'am. Pungudi, ma'am.
I'm teaching 10th standard, 9th, 10th, and 11th also.
Okay.
But for 12th, this time they have given practical. With the external will be coming. So I need a clear idea for that with the practicals.
For which grade, ma'am?
Actually, 12th standard, but 10th standard, we are just going with only the sample things like data visualization, collecting the pictures, and like that we go.
Okay. So
I'm the Chetpat is our actually main branch, Maharishi Vidya Mandir. So then they have 50 marks. It is split into 15 marks for the practical and the 15 marks for the work they are doing, the lab manual, that is practical record book, and 15 marks for the project and 5 marks for the Viva. So it will be from the SDGs, 17 SDGs, they can take any one thing. And what will be now, for example, it is no poverty now. now they will be collecting the pictures. That is data visualization. And how come they are going to solve that? That is the main thing, that prediction like that. But we don't use orange binding tool. These are the things we have to follow. Like that, I need a clear idea about it.
Ma'am, I'm not very clear of your question. So which grade level you are asking for this, ma'am?
If it is 10th standard, it's okay for me. But the 12th, now this is the first year for us. We are going to do that. Because
Actually, ma'am, actually for grade 12, there is no bar from CBSE side that what kind of project you are making. You can make it as a low code also. You can make it as a high code also. So we can have the project in either in teachable machine manner or orange data mining tool or only of the Python code. There is no bar from CBSE.
Okay.
So because we are getting the mixed bag of students in AI. Like humanities are also there, humanities students, science students are also there, commerce students are also there. So those who are interested in Python, they can make it as a Python base. A few are creating as a low code in teachable machine or either from the Google side or from the MIT app inventor if their logics are very clear in the visual programming. So they can create it from MIT app inventor. And moreover, a few have taken some other app creator in the manner they have, because in grade 12 basically we are accessing three things. The first is a project, the second thing is a cookbook of the project, and the third thing is a video of the same. And that video, we need to upload the video on YouTube or either any platform you can upload, and the link has to share in the cookbook itself. And examiner is evaluating the video also, and examiner is evaluating cookbook as well as the project. It all depends upon, because it's a group project. There are 5 students, 3 to 5 students are there in a group. So it all depends. So if there are 3, you can go for any teachable machine. If there are 5, they are interested, keen in for Python, you can have some Python code-based project. Or if they are interested in MIT App Inventor, they can go for that also. They can create any, because nowadays so many platforms are available for creating the app. So they can have that app creation also.
Oh, sure. Okay, ma'am. Thank you so much, ma'am.
And if there is any query, you can ask related to, because my 2 batches of 12th AI has gone successfully.
Okay, ma'am. Sure. Thank you so
And
much.
actually this time the syllabus has changed, so we are also in dilemma what to do, what not to do, because their Python at length there without any description even given in the chapter. So, So ऐसा लग रहा है CBSE has not provided any workshop till now for grade 12 AI.
Yes.
So हम सब आपस में ही discuss करके and then we are just doing the same.
Yeah. Correct, ma'am. Thank you so much, ma'am. Thank you.
Thank you so much, ma'am. It's nice to see how we are all helping each other to get into this AI mode. Actually, like the subject is new for, like, of course, for everyone. For everyone, it is new. When they start for the first time, it's going to be.
Yes, no. Other than that, AI is. I'm learning new things daily, and going into it. So CS, I don't like now. If at all they give AI for me, 12th, it's well and good. The children itself say, ma'am, don't know CS, Java, CS, and AI teach like that. That they, because whatever doubt is there, I used to clarify them and I give the real time example and each and everything. So they are much thorough with that thing.
Okay, good, ma'am. Good.
Okay, ma'am. Thank you so much, ma'am.
Yeah.
But can't we have in orange data mining, can't we have some textual, like image identification is there? Can't we have such thing like numbers are there, by the numbers it was being identified. But can't we have some text like it would be most appropriate for banana in this? Because nowhere I am getting this कि हम ना कैसे orange data mining पे text लेकर आ जाएं ताकि बच्चे को भी एक बार दिखे कि हाँ if it is a this picture is resembling with this image and it would be the banana, it would be a strawberry or something like that.
That is the thing we are learning, ma'am. In 9th standard itself, there is a question. based on that. So that is only explained here through the model and how
Ma'am,
it is
I
predicting.
I agree that because every time the target we are taking the numeric value. So what am I thinking if we'll take, because I tried and I was not getting some satisfactory result. That's why I'm asking over here.
Okay. Whatever
We have
we
to
did
work
now.
out with orange mining, then only we will be getting a clear idea. Just she is doing and we are listening, no. So after 1 or 2 days, we will forget. Again, we have to go and work it out, then it will be clear for us. I have attended 2 sessions, so a little bit okay for me now.
Okay, yeah. Yes, ma'am, you need to get the hang of the tool. So for that,
Yeah,
you need
of
to
course.
yes, try with different data sets. You can download the different data sets from Kaggle and try to do it with different
Yeah,
data sets.
Kaggle, we will get more things.
Yes.
Ma'am, the only problem is that we students will get very little time. I mean, we can keep on practicing with this just
The
one or
only
two
thing is there are
sessions in
so
a
many
week.
AI tools. We should know which tool must be used for
Yes,
which.
yes.
That
So
alone we should learn. That's the main thing that we should
yes.
be thorough. Otherwise, we can't do anything.
Yeah, and then children will get even more confused if, like, I mean, and we will be having very less practical periods for this, because as and when by November, so it's a little bit difficult to. We have to be absolutely thorough and then start teaching this, right?
Yes, of course.
Yes, ma'am. Okay. So thank you so much, everyone. Have a great evening. So we will again see you all in the next AI bootcamp. But anything that we want to have discussion, then like how we are doing now in the live session, we can also do the same thing in the WhatsApp. So keep the discussions going on. Yeah.
Sure.
Thank you so much, everyone. Yeah. Bye.
Thank you.
Thank you, Ramya ma'am. Thank you so much.
Yeah. Thank you.